1.3 algebraic properties is our next section. First thing to talk about is what is an expression. An expression is a mathematical phrase. You've been dealing with these since elementary school. Um, you can have numeric expressions, which is what you would have been dealing with in elementary school. They're just math phrases that only have numbers and operators. For example, 2 plus 2 is a numeric expression. 7 minus 5, 1/2 times 4 plus 7 divided by 2 is a numeric expression. So then an algebraic expression, algebra always involves variables. Okay, so you still have the numbers, you still have the operations, but now we throw in those variables. 2x minus 7 is an algebraic expression. 3y, 1/2 z squared plus 7 divided by 9x. Okay, so those are all expressions, different kinds, whether they have numbers or variables as well. Okay, here's our properties. Commutative property and associative property. You can see they both have addition and multiplication. These properties are things you already know. You just probably don't always remember the name for them. The commutative property of addition says if you have A plus B plus C, that's the same as if you have A plus C plus B. So what's the difference? The B and the C switched orders. We could also say that x plus y is the same as y plus x. You're changing the order. For multiplication, same idea. You could do A times B times C, and that would be the same as if you did A times C times B. We know that order doesn't matter when we're doing addition or subtraction. Okay, so you could have y times x being the same as x times y. Okay, so then what is associative property? Associative property says if you have A plus the quantity B plus C, or grouping B plus C, that's the same as if you would be grouping A plus B and then adding C. Likewise, for multiplication, you could have A times the quantity BC, and that's the same as if you multiplied A times B first, group that together, and then multiplied by C. So commutative property always deals with the order is what is changing. Okay, so we had ABC, now we have ACB. The order changed. For associative, the order doesn't change. They all say ABC, ABC. It's the grouping that changes. Okay, don't confuse the two. Order changing or the grouping changing. Little way to remember that, who you associate with. We can see the word associate in here. Who you associate with is your group. Your group is who you hang out with. It's who you associate with. So that's how you can remember that. Okay, we've got some different expressions. Actually, we have equations, but we're looking at them as two separate expressions. This expression and then this expression. We want to see, first of all, are they actually equivalent? Are they equal to one another? And if so, we want to state the property that is showing that they are equal. So for the first one, we have x plus y plus 2. Is that equal to x plus 2 plus y? Sure, we know those two things are equal. Which of those properties says that's the case? Well, what has changed from the left side to the right side? Your order here has changed. Your y and your 2 switch places. Which property is it when the order changes? That is commutative. Okay, I don't mind if you abbreviate, COMM. Second one, 8 minus 6 equals 6 minus 8. Are those the same? I don't think so, because 8 minus 6 here would be 2. 6 minus 8 would be negative 2. Those are not equal. That's our not equal symbol. So we can simply say a big not equal symbol. So there's no property being used here. This would be, technically, it would be commutative property of subtraction. That's not a thing. It's only of addition or multiplication, so that is not equal. How about 8 minus 6 and negative 6 plus 8? Well, 8 minus 6 is 2. Negative 6 plus 8 is also 2. So those are equal. We need to figure out which property says that. And this time, again, we're changing the order. That is commutative property. So why did it work here, but not on that one? Well, on this one, we switched the numbers, but we didn't keep the sign. So this one was negative 6, and it's still negative 6. Positive 8 and still positive 8. Versus over here, our positive 8, became negative. Okay, so you didn't switch the whole number, you just switched the numbers and did not look at the sign. Okay, on the bottom, this one is all multiplication, and we've changed the grouping. So they both say 4xy, but we've changed what is grouped. That is definitely going to be then associative property. If you're going to abbreviate it, don't abbreviate it too soon. Go all the way out to here. Next one, we have all addition, and we have them all in the same order, 5x2, 5x2. So that rules out commutative. Is it associative property? Did your grouping change? Sure enough, it did. So we have an associative property. Last one, we have some addition and some multiplication. Did our grouping change? No, we still have b plus c. That has not changed. Did our order change? Well, we started with a, b, c, and we went to b, c, a. So we would be thinking about commutative property, but one thing we didn't look at, are they actually equal? If you're not 100% sure, plug some numbers in. Let's let a equal 2. Let's let b equal 3, just picking random numbers. And let's let c equal 4. So I have 2 plus 3 times 4 is 12. 2 plus 12 is 14. Over here, 3 times 4 is 12. 12 plus 2 is 14. So sure enough, they are equal, and it is commutative property of addition. So even though we had multiplication happening, it's the addition commutative property that is actually occurring. Okay? By the way, I didn't say this, but at any time, if you need to pause the video, do that. So it might have been a good idea, I wish I could rewind and tell you this, might have been a good idea to pause the video and write these examples down. But hopefully you did that and you are with me now. If not, pause it now and go ahead and get your stuff down. Okay, we're going to do some proofs. Proofs are a mathematical way to show that something is equal to something else. Okay, you do a lot of these in geometry, but we just do a little intro in Algebra 1. So we want to prove that quantity xy times z is the same as the quantity zy times x. Logically, we should know that's true because really this is just multiplication of 3 numbers, and we know we could group that and change orders, and none of that's going to matter. It's all going to give you the same answer. So the very first one is always going to be your given statement. It's the left side of the equal sign. And then I've given you the steps, and what you need to be able to do is to justify them. Essentially, you're going to tell me what property you used to get from the first step to the second step, then the second to the third, and then finally the third to the fourth here. So if you look from your first step to your second, what has changed? Well, I see that my z was in the back and it came to the front. So the order changed. That's commutative property. From my second step to my third step, what has changed is, again, the order. It's the order of what's inside the parentheses. So order is commutative property. And then finally, from my third to my fourth step, what has changed is my grouping. So my zyx, the order is still the same, but the grouping symbols have come off of here, off of yx, and moved on to zy. When grouping changes, it is the associative property. Okay? Go ahead and pause the video, see if you can come up with your steps for your second proof. Okay, I have my first given x plus quantity y plus z. So if you look from there to here, What has changed is the grouping symbols. The XYZ order has not changed, but my grouping symbols moved. That's associative property. Then into my next step, my order has changed. My Z went from the end to the front, back to the front. Order changing is commutative property. So hopefully you got those. If not, go ahead and correct them. All right, and then our big one, distributive property, gets used all the time. And this is one that students remember the name of because we use it all the time. Distributive property says if you have A times a quantity B plus C, then that is equal to A times B plus A times C. We distribute that A to everything in the parenthesis. On the first problem then, you would distribute your 4 to the 2. 4 times 2, we know of course is 8. And then you have to distribute it back here, so plus 4 times 3, which is 12, to give us a final answer of 20. However, on this problem, I would not suggest you use distributive property. Distributive property is more helpful and more useful when we have variables in here. The reason I wouldn't use it here is because I would just use order of operations. Order of operations says we do parentheses first. And 2 plus 3 would be 5. And you'd still have the 4 out front, which means multiplication. 4 times 5 is 20. So we get to our answer a lot faster just using order of operations. The problem with order of operations is you cannot simplify inside these parentheses on the next two problems. If one term has a variable and the other term does not, they are not like terms, so you can't combine them. What you would have to do instead to simplify a problem like this is distributive property. 2x is all one term, so we just distribute the 4 to it one time. And then we also distribute it to the 3. 4 times 2x we know is 8x, and 4 times 3 is a positive 12. Last problem, you want to distribute the entire term out front, which is negative 4. Don't forget about your sign. There are 2 terms inside there, so we distribute it to the 2x and to the 3. My arrow didn't quite get there. To the 3y. So negative 4 times 2x is negative 8x. And again, watch your signs. Negative times a positive is negative, and 4 times 3y is 12y. So negative 4 times positive 3y is negative 12y. In these two, you have unlike terms. This has an x, this doesn't, so you cannot combine, you'd be done. And over here, this has an x, this has a y. Those are not like terms. You would be done there as well. All right, moving on. Okay, distribute and combine like terms. Remember, like terms have to have the same variables. So on our first one, students all the time, they want to put that as an 8. It's nice, easy addition. We just want to get it done. But unfortunately, you have to use those order of operations. Keep in mind, order of operations says multiplication, which is occurring right here, has to be done before this addition. So we cannot combine that. We have to distribute. We have to distribute because inside those parentheses, we could not simplify. So we have 3. That's just hanging out front. We're not doing anything with it. We are distributing a positive 5. That gives you plus 5x. And then 5 times negative 8 is negative 40. Combining like terms, well, 3 and negative 40 are just regular old numbers called constants. And we've always combined those, so we're going to go ahead and combine them now. Those are like terms. 3 minus 40 gives you negative 37. And then plus 5x comes down. Okay, the second one. Taking a look at this problem, think of order of operations. You would first do parentheses. However, this has a variable, this doesn't. They are not like terms. So we can't do anything in our parentheses. We have no exponents. The next thing to look for is multiplication. And while you don't see any time signs in either way we've ever seen them, we do see it in the parentheses. So we know there's multiplication here. We're going to distribute right there and right there. 2h just gets brought down. We're not doing anything with it yet. What are you distributing here? Don't forget to include your sign. The sign, you always, when you have a term, you look in front of it for the sign. That has to go with it. So negative 4 times 3h is negative 12h. And negative 4 times negative 7 is positive 28. Look for like terms. These both have h's. Combine those. 2h minus 12h. Well, 2 minus 12 is negative 10, and then you just attach that h to the end. If you have anything left over, bring it down, like the plus 28. Those are not like terms. One has an h, one doesn't, so you are done there. Okay, go ahead and pause the video and work out the next 4 problems. Okay, check them out, see how you did. Hopefully you didn't make any sign errors. For the first problem up there, you're distributing a negative 4. This negative 6 is just minus 6 at the end. So your negative 12 and your minus 6 combine to negative 18. Second one, well, the fourth one on the page, second one you are doing, you're distributing the 2. You get 10 and 6d. Combine your d terms, 7 and 6, to get 13d plus 10. This one, hopefully you did not get tricked. Don't combine the 8 minus 3 first. That is not the correct order of operations. You need to do the multiplication, which in this case is distributive property, before you do the subtraction. What are you distributing? I underlined it, negative 3. So that means you have negative 6t, and then this negative and this negative become positive. Combine 8 plus 15. Sometimes students will want to do 8 minus 15. You don't use the sign behind a term, you use the sign in front of a term. So positive 8, positive 15. That negative sign goes with the 6t. Lastly, a fraction. Don't be scared of fractions. They're just regular old numbers. We should not be nervous around them. 2/3 times 3x is 2x. 2/3 times 6 is 4. And then we end up bringing down the plus 12, combining it to get 16. Okay. Another proof here. It looks like we are doing some distributive property. So we want to look at how we're starting with this, how we end up getting that. Doesn't look like too many steps here. The first one is always given to you. Left side of the equation is given. What has changed from here to here? Well, it looks like my 2 went from the back to the front. Which property is order? It is commutative property. Okay, then with that 2 in the front, how did they go from here to here? Well, they must have done distributive property. So distributive property is your last reason. Okay? That is all I have for you. Go ahead and keep working on the rest of your packet.